Okay, let's see. Suppose we have a positive charge here. So lines of force is nothing but a way to visualize uh, the effect it would have on surrounding charges. Any charge has an effect on the other charges surrounding it, and lines of force just tells you what the effect is. So if you were to place a small positive charge over here, what would it do? Suppose there's a small positive charge.
It
It would
would
feel a force due to this larger charge
it would
in
repel it.
this direction, somewhere radially outward,
Yeah.
and it would keep moving away. So
Mm.
it will be repelled. Something here would feel a force in this direction. Someone here would feel a force, a feebler force in this direction. And someone very near would feel a very strong repulsive force.
Yeah.
So this thing is codified in the lines of force. So lines of force are uh, generated. So for a positive charge, it would be outwards. Everything goes outwards because a small positive charge placed near that would feel a outward force. So if I remove this, lines of force for a positive charge go radially outwards. So this tells you the path a small positive charge would take if you were to place it
Mm.
somewhere here. What about a negative charge? Can you guess?
The negative charge, uh, if there were positive charge around the negative charge would be attract, but if it was
Right. So
if
everything
it
goes
would
inside,
attract, yeah, goes inside.
radially inwards. So these are the lines of forces if you have only a positive charge or only a negative charge in your universe. But what happens if you bring them together, bring them close to each other? That's an interesting situation. You have a positive charge and a negative charge, and they are close to each other. What would happen then?
Then it would connect, right?
Exactly. So, say you leave a very small positive charge here. It would start being repelled by this, but soon enough,
It will
so
attract to the this
it'll get
negative.
attracted to this
Yeah.
and it'll bend and reach this charge. So, it's something like this, very near it. And the direction would be from the positive to the negative.
Yes.
And these lines of force would also bend. Sorry, the other way. Something like this. So, lines of force actually tells us a few things. The density of lines of force in any region of space is a measure of the amount of electric force that something would feel there.
Okay.
Okay. So, if you see that here, number of lines of force is very less. So, people won't be feeling much force, so charges. But when you go here, there's a lot of lines of force, very dense amount of lines of force. So, the amount of force would be more. Another property is lines of force cannot intersect. Why
Yeah,
is
I
that?
can expect. If it were to intersect, then the direction would be what do you say
Ambiguous?
changed. So if
Exactly.
it cannot be intersect, and the what do you say the force near the electron or proton is the strongest point there. It has the strongest force.
Right. So what is it telling me? Lines of force are telling me if I place a small positive charge there, what would its motion be like at that point? That's what the line of force is telling me. So what if it were to intersect? Then see, say a charged particle was traveling along this path
Hmm.
and it came to this junction where there is an intersection of lines of force. Now the charged particle is confused. Which way do I go? It cannot decide. So that
That's-
cannot happen. It cannot go on both directions at the same time. So that's why this is physically not possible to have a intersection between lines of force. Okay. What happens if you bring two like charges together, say two positive charges?
Then it would repel.
Lines of force would repel. Exactly. So lines of force going in the same direction tend to repel. The lines of force would go out like this.